All right, example number 8. We're going to use the same rod as last time. I'm not going to redraw it. But this time, the linear density is not constant. The density of the rod is actually going to increase as you go farther from the origin. And for this problem, we're going to assume that lambda varies linearly with x. So lambda equals alpha x. Alpha is just a Greek letter that we're using as a constant. So the farther you move from the origin, the greater x is, the greater the density is. All right, so that's going to change our result because the right end is going to be more dense than the left end. Our last example, the whole thing was the same density throughout. But one thing that stays the same is the differential mass is still whatever our expression for lambda is, whatever our expression for linear density is, times that infinitesimal little bit of rod. So, going back to our expression for center of mass, 1 over mass, the integral of x dm. Okay, that's the same. Now we're starting to put in our expressions that are specific to the situation. Let's first substitute for dm. So 1 over the total mass, integral of x lambda dx. Okay, but now we know also that lambda equals alpha x, okay, from up here. So let's put that in. So that's 1 over m, the integral of x alpha x dx. Now alpha is a constant. Okay, so this whole thing equal alpha over m, the integral from 0 to L over the whole length of the rod of x squared dx. We do that integral and we get alpha over m, x cubed over 3, evaluated between 0 and L. So we end up with alpha L cubed over 3m. Okay. So we're not done yet because we can simplify this. And we can simplify this by looking at the mass. The overall mass is the integral along the whole rod of all those little masses. Now remember dm up here is equal to lambda dx. All right, and remember that lambda equals alpha x, so 0 to L alpha x dx. So when you do this out, you end up with alpha L squared over 2 for m. Okay, this equals m. Now, put this in here, and this is going to simplify things. So x cm equals alpha L cubed, just rewriting this so we know where this comes from. Alpha L cubed over 3 times, and now this goes in here, alpha L squared over 2. Okay, so this goes with that, this goes with that. So we end up with the center of mass is 2/3 L, which, if you think about it, is really not a surprise, as the density varies linearly from the origin at a minimum to maximum at L. You'd expect it to be right there. So again, not a complicated problem, but it gives you confidence that the procedure works.